The piercing sound of the alarm clock shatters the pre-dawn silence. It is 5 o'clock in the morning. For a second-year medical student, this early call is routine. It's a non-negotiable start to a demanding day. The aroma of brewing coffee slowly fills the small kitchen, promising a much-needed jolt of energy. My mind still feels heavy with sleep, but there's no time to linger in that sleepy state. Physiology waits for no one. Important concepts need reviewing before class. I reach for my well-worn physiology textbook. Notes are scattered across the desk, and diagrams of complex feedback loops seem to jump out. Topics like cardiac cycles and glomerular filtration rates demand attention. These aren't light subjects for an early morning, but this initial review helps to set the stage. It prepares my mind for the dense information to come. Every minute of study counts in medical school. This quiet time is surprisingly precious. It's a calm before the storm of lectures. The next hour involves a whirlwind of preparation. I pack my heavy backpack filled with textbooks, notebooks, and my laptop. My stethoscope, a symbol of the future, is carefully placed inside. I run through a mental checklist. Are all lecture notes printed? Is my water bottle full? Breakfast is often a quick, utilitarian affair, perhaps a piece of fruit or a granola bar, eaten on the go sometimes. The commute to the medical campus begins, and this travel time is another opportunity for a quick review. Arriving at the lecture hall, a familiar buzz greets me. Fellow students are already gathered. Some are animatedly discussing last night's challenging topics, while others sit quietly, eyes glued to their notes. A shared sense of purpose hangs in the air, along with a palpable sense of pressure. Physiology is a mountain we all must climb. The sheer volume of information can feel overwhelming. The professor enters, the lights dim slightly. The first physiology lecture of the day is about to commence. We must be ready to absorb. Physiology is the cornerstone of medical education. It's the scientific study of function in living systems. It explains how our bodies work, from the smallest cell to the most complex organ systems. It delves into the mechanisms that maintain life. Understanding these mechanisms is absolutely fundamental. Without a solid grasp of physiology, medicine becomes guesswork. It is the science that underpins effective diagnosis and treatment. It truly is the body's operating manual. Physiology serves as a vital bridge, connecting the basic sciences with clinical medicine. Anatomy teaches us about the body's structure, biochemistry explains the chemical reactions, but physiology shows how these structures and reactions work together. How does the heart actually pump blood effectively? How do our lungs extract oxygen from the air? These are questions answered by physiology. It transforms static knowledge into dynamic understanding. This understanding is critical for any aspiring doctor. It helps make sense of the human machine. A deep understanding of physiology moves students beyond rote memorization. It allows them to grasp the behind diseases. It's not enough to know the symptoms of a condition. A doctor must understand the physiological disruption causing those symptoms. Consider a patient presenting with unexplained edema or swelling. Physiology explains the delicate balance of fluid dynamics involving hydrostatic and osmotic pressures, known as Starling forces. Understanding this helps pinpoint the cause, leading to better, more targeted treatment. Let's take a common example. Blood pressure. We see it measured constantly. It seems like a simple number, yet physiology reveals the intricate processes behind it. Blood pressure is determined by cardiac output and is also affected by systemic vascular resistance. Hormones like adrenaline and angiotensin play crucial roles. The kidneys are also deeply involved in long-term regulation. Understanding this complex interplay is essential for managing conditions like hypertension. This is physiology in action every single day in medicine. Physiology lectures are notoriously dense. Information is delivered at a rapid pace. Students are bombarded with complex pathways. Numerous feedback loops must be understood. The renin-angiotensin-aldosterone system, for instance, is a classic example. It involves multiple organs and hormones and can seem overwhelmingly intricate at first. Effective note-taking becomes an essential skill. Active listening is equally important. Every slide, every explanation holds key details. Missing one piece can make the whole puzzle harder to solve later. Problem-solving sessions present their own unique challenges. These sessions require students to apply physiological principles and often involve clinical vignettes. A hypothetical patient case is presented. Students must predict the physiological consequences of a specific change. What happens if a particular hormone level is elevated, or if a certain ion channel is blocked? These exercises rigorously test true understanding. They go far beyond simple recall of facts. They cultivate critical thinking. These sessions are incredibly valuable learning opportunities despite their difficulty. Laboratory sessions offer a welcome change of pace. They provide hands-on experience with physiological concepts. Students might measure their own lung volumes using a spirometer or record and interpret an electrocardiogram, ECG. Seeing these processes in action makes them more tangible. Abstract concepts from the textbook come to life. However, labs also mean more work. Detailed lab reports must be written. Data must be analyzed and interpreted correctly. This adds to the already heavy workload. One of the biggest challenges is integration. Physiology requires connecting information from different organ systems. The respiratory system does not work in isolation. It is intimately linked with the cardiovascular system. The renal system interacts closely with the endocrine system to maintain homeostasis. The human body is a network of interconnected systems. Physiology reveals these intricate links. Learning it can feel like assembling a giant, complex jigsaw puzzle. Each piece, each system must fit perfectly with the others. This requires patience and persistent effort. Those aha moments in physiology are incredibly rewarding. They are flashes of insight when a difficult concept suddenly clicks. All the seemingly disparate facts fall into place. The Fick principle used to calculate cardiac output might initially seem like just another abstract equation, but when its application is understood, it becomes a powerful diagnostic tool. It represents a deeper level of comprehension. These moments of clarity provide much-needed motivation. They fuel the desire to learn more and push through challenges. They are small victories on a long road. Physiology provides the essential framework for understanding disease mechanisms. This is the realm of pathophysiology. Consider a condition like type 2 diabetes. Physiology explains normal glucose metabolism. It details the role of insulin and glucose transporters. Pathophysiology then explains how insulin resistance disrupts these processes. It shows why blood glucose levels rise. This understanding is crucial for educating patients about their condition. It also guides physicians in selecting the most appropriate treatments. This knowledge is truly powerful in clinical practice. A strong foundation in physiology is critical for future medical studies. Subsequent courses like pharmacology, pathology, and internal medicine all build upon it. Understanding how drugs affect the body, pharmacology, requires knowing normal body function. Understanding how diseases alter the body, pathology, also needs this baseline. Success in these advanced subjects often depends on how well physiology was mastered. It is an investment that pays dividends throughout a medical career. It is not just another subject to pass, it is foundational. The journey through second-year medical school is undeniably demanding. Physiology often stands out as a particularly formidable hurdle. Yet, successfully navigating its complexities is transformative. It fundamentally changes how a student perceives the human body. It shifts thinking from a list of parts to a dynamic, integrated system. Mastering physiology equips future doctors with essential critical thinking skills. It prepares them not just to treat symptoms but to understand and address root causes. This is a vital step on the path to becoming a competent, compassionate healer.